Hey everybody, this is Larry, this is me over Q4 of the Bi-Weekly Contest 132, Longest Special Path 2. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this one. This one I didn't solve during the virtual contest. I'm a little bit disappointed. I solved about like 20 minutes after that. Mostly because it's one of those problems where once you solve it, you're like, oh, this should have been obvious. But I think the key part about this is kind of interesting. I'm going to start by going through my thought process during the virtual contest and how I solved it, and then I just kind of go over it next. Another key thing I would say is that for this particular problem, it turns out it's very, very similar to the first version of it, where you have where this exception is not true, where all the node values are distinct. Anyway, it is even going through the wrong answer. It may not and did not apply for this problem. There are some interesting components of this, right? In terms of observation, the first thing that I did was I was trying to do sliding window, and the reason why sliding window don't actually work is for a reason I'll go over in a sec. But the idea that how I would think about these is that instead of writing a tree from top to bottom, I'm going to write them from left to right? So maybe you can have a tree that goes like this. Right? And then, it goes like this, maybe, right? Something like that, right? And, each of these could be binary and so forth, right? And then the idea here that I had is just using sliding windows. Because the way that I thought that I could have done was that, okay, well, how is a sliding window work, right? Well, sliding window, we just keep track of the left and a right node, and then as we kind of move, we just move, right? And then the thought that I had is that when we go back on the recursion, we just have to reround these things. The reason why it doesn't work is, well, actually, let me step back for a second, and is that for this we should be able to get at least an answer. I mean, it's going to be too slow for a case that I'll point out in a second. But the idea here is prefix sum, right? So we have this length thing, right? So if we keep track of, so let's just say here, let me change colors. Let's say here the prefix sum is 0 on the length, and then here there's 5, there's 7, and maybe 20, right? So if the left is on this node and you're on this node, then here you can use the prefix sum to say that this is 15 length altogether, right? In between the 5 and the 20. So that's basically the idea that I had for this one. The reason why this doesn't work real quick is because if you have a case where, because the way that I did sliding window initially was that I was sliding one at a time on the left and on the right. So my idea or my thought was that if I, it was a proof on the bounds where we only increment the right n times. So that means that the left only increments n times. But it turns out that I was wrong because I was hoping that was right, but it was wrong anyway, right? So the edge case is that you have like a lot of nodes here, and then now you have a store node thing, right? The thing is that let's say you're here, and now if you have a window where this is the left and this is the right, and you're sliding in such a way, maybe I didn't go over the sliding windows that deeply, but the sliding window is that we slide to the left to ensure that the invariant is true, which is that within the window we have all distinct nodes except for one of them, right? And here, the idea here is that every time we go back, well, we just slide back and we're fine. And for a tree like this, is fine because it's roughly 1 to 1. But for here, apparently, if I was not careful, then here we can on this node we can slide like say roughly n times. Then here we can also slide roughly n times, and then now you have all these n squared type things, right? Let's say you have n nodes, each requires n times to slide, then you have n squared. So sliding window for this particular case is not good, even though it would give you the answer, just too slow, right? if you try to slide one node at a time. And I was thinking through ways to hack around this, honestly, during the virtual contest. It's like maybe I could store things here, but I couldn't really work it out because the states are not distinct, right? You have things where like it matters what you fire out the window, because the colors of these nodes will determine a lot of things as well, right? Okay. I just want to this part isn't super important, but I think well, the prefix sum part is important, but the sliding window part for this particular problem isn't super important. That's why I'm not going into super long detail, but I just want to get that idea in your head. For some other problems, it may make more sense, but for this one, I couldn't get it to work. And I was even thinking about going from the leaves up and try to see if maybe I can figure out to kind of merge them in best out way. And honestly, I was not able to. And then I had this idea that I had to use segment tree. And this is actually the first solution that I came up with a little bit after the contest. But the way that I thought about it is, okay, let's step back for a second, right? Let's try to, and you don't, just to be clear, you do not need segment tree. We'll go over a solution where you do not need the segment tree. But this was the way I was thinking about it, and I thought, Leetcode's been kind of annoying lately. They've been doing a lot of segment tree. Maybe I need a segment tree. Again, I will go over a solution where you do not need it, but I thought that you might have when I was writing it, right? And the first thing I thought was, okay, let's step back for a second and think, right? Okay, so there's except for one value that appears twice. So how do I solve the case in which we just ignore the at most twice part, right? Which means that all the nodes are distinct. It turns out, well, you can pause the video. I think the video I did last time was actually detailed on the longest special path 1. There's no 1 because they didn't have a second one yet. But if you Google for that, and I'll go over that a little bit later, I give a good explanation there, I believe. You could be wrong. But the idea here is that, okay, so let's say you're given a node, a tree rather, right? And it has some colors, right? So then the question is, yeah, so if a distinct thing, then that means that here, let's just say we took a path, right? Change the color real quick, actually. Let's say we took this path, right? Then what does that mean? That means that we have gotten 5 colors, right? So in 5 colors, and maybe a 6th color, right? Let's say we have 6 colors. Well, we have 6 nodes anyway. Maybe not 6 colors. And then what does that mean? Well, that means that honestly, I didn't. Now that I know the other way of doing it, it's one of those things where I wasn't sure what I was thinking. But the idea I had was that, okay, well, given this, what is the closest dupe node there is, right? And here, it may be that for this dupe node. So what I do is that when I do a recursion, when I go down the stack, I set the segment tree of that color, right? And for this one, you don't want a duplicate. So for every duplicate, so there are 2 things. One is that I keep track of the nodes and the depth. And for the depth, I keep track of, so for each node color, I keep track of the nodes that, so for each color, I keep track of the depths that color appears on, right? So for example, okay, yeah, just want to be precise. So for example, maybe this is red, right? Maybe this is red, maybe this is red, maybe, yeah, let me just draw in some colors. This is green, right? Maybe this is, I don't know, is that purple, purplish? And maybe just right? Okay, so that means that, for example, I keep track of red. This is depth 0. This is depth 2, right? So then red I would maybe store is equal to 0, 2. And here, in the segment tree, I would store the number 0, right? Because 0 is what I would call the cutoff point, right? Because here, this is... keeping in mind that this is for all distinct nodes, then we know that this is the cutoff point because no matter how far you go deep down, you cannot go above this, right? And that's just only for red. For example, for green, we have an array of 1, and we have, was it 3, 4, say 4. I think that's the same green, right? 1, 4. Then here, our cutoff point for green is 1, right? Because it is the second to last item. So that's pretty much it, honestly. Yeah, because from that, then now we just have to keep track of stuff like this, right? Yeah. Because then now, what the segment tree allows us to do is just get the max of the entire tree of these values. And also, so one thing it allows us to do is get max of these values in a very quick way, because we want, okay, for all these colors that we have, what is the latest cutoff point? So that's what the segment tree is supposed to answer for us. And the reason why we like the segment tree is because then now we're able to, when we go down the stack, we're able to set these. We're able to update the segment tree very quickly, and when we pop back off the stack, we're able to reset or unset the segment tree also very quickly. So that's really the idea behind this, is that we're able to kind of get the max of every color's cutoff point, and then from that, we're able to kind of just do math on the prefix sum. Again, prefix sum, for example, for here, we might, for the green nodes, for example, along the stack, we may store, okay, for this node, we may store, okay, the node is 0, the total length is 0, right? And here, the node is 1, and the total stack, or the total, the depth is 1, the total length may be, I don't know, 0 plus 5. If this edge is 5, then it's 5, and so forth, right? Dot, dot, dot. So with that, you can keep track of the previous step. For example, if you just do here, maybe on the green, on this green, the depth is 4, the length is 20. Then here, from here to the last green, is just 20 to 5, right? So okay, so that's really the idea for using a segment tree if it's all distinct, if there's no nodes, right? That you need more than, that you can have more than 2 of any nodes. So how do you solve this for at most 2 node case? What I did was that I just kind of cheated a little bit, right? I go, okay, let's say we are at this point, right? So at this point, we go, okay, we take the max of everything. We know that the max now from our segment tree, the max is 1, right? So then I go, okay, well, what if that is, I mean, the closest one is going to be the one that, for obvious reason, is the one that we want to have 2 of, right? So in that case, what happens? Well, let's say we remove this one from the segment tree. What would be the next cutoff point? And then we ask it again. So that's really it. I manually remove 1 point from the segment tree on every query, and then I go, okay, what's the previous, or what's the next max? And that's it. And so what's the next cutoff point after this cutoff point? So that's basically the idea here using the segment tree. And there's also another edge case where maybe let's say this is green as well. Then now green is equal to, was it 1, 3, 4? So then the cutoff point is actually at 3. So there is a case where you set this cutoff point to the point before that, and if you do, then 1 will be the new cutoff. So there are some like edge cases, but that is the general idea. And with all that said, so if you're able to get the longest path, and keep in mind that what we just solved was also the longest special path part 1. If you solve part 1 with that segment tree, all you have to do is just add that extra tweak of, okay, let's remove the biggest, or let's remove the closest cutoff. What is the next closest cutoff? And that's it. This is not that code. This is the other code. Let me find it real quick. So yeah, so that's basically it. If this wants to load, technical difficulties. Yes, I think it's this one. I forget what I. Nope. Okay, yeah. This is way long and awkward. I know, it's Q4, right? Sorry, friends, technical difficulty. But I want to go with this solution real quick first. And yeah, so I'm not going to go over segment tree for this video. This is a template that I had. I don't know if I probably wrote most of this, making changes to whatever. I don't know. Is it a good template? I don't know. It's good enough, I suppose. But yeah, but we'll focus on this part here, which is the code. So first we set up the tree to use adjacency list, and then we call the stack of the numbers, right? So this num stack was what I said for each color. It maps the depth of the stack that is currently in there. And then we have two things. These are the return variables of the longest string and the minimum number of nodes of that longest path, right? And I have segment tree using -1s. I don't know about that, but stack, right? And here we started the recursion on the first node. And on the first node, we push the node and the prefix sum, the prefix weight, if you will, on the stack. And we also take the depth. We go, okay, well, given this node, given this color actually. So maybe we can be a little bit clearer. Color is equal to num sub node, right? Because that's what this nums really is. And then we set that to be, we add it to the depth. If it has 2 or more items, then we set the segment tree to -2, right? The second max element, right? And because we always append them in increasing order, this is going to be the second biggest number, or the second closest depth, and this is the cutoff point, right? Set the cutoff point for this color, right? And that's basically what this does. And then now, so this is just setting up the current state of the tree, right? So then now, if you want to think about loop in, well, it's not a loop invariant, but invariant is that at this point, as the segment tree contains the cutoff points for all the colors, right? And then now, so then we get the cutoff point of all the colors, and that's what this does. And then I go, okay, well, let's remove one cutoff point. And that's basically what this code does, is that if the node has 3 or more, we just want to update the segment tree to either because if you have two nodes at that same color, then now you want the third largest, right? So that's what this does. If there's 3 colors, then we just set that colors to the third depth. Otherwise, you set to -1 as kind of a, like, it's off the off the root kind of thing, right? It doesn't exist. And then now we're able to get, so at this point, st contain the cutoff of all the colors minus the recent cutoff, right? Because we just removed the cutoff here. Yeah, and I had a lot of print statements. Maybe I'll remove them for debugging because I was running into issues. And then now, after that, we're able to get the best depth. This is just a straightforward comparison, right? Not going to go over that deeply, but this is prefix sum, so maybe I'll go over it a little bit. The length is that, okay, so, and maybe length of stack is a little bit awkward because I think that's just depth, right? So depth is the current depth. Let me actually run it real quick so that I don't lie to you, or off by 1. Maybe it is off by 1 because the current depth the length of the stack is the current depth minus 1 or something, or the other way around. But yeah, so, and then we're gonna submit that. Maybe that's a little bit clearer, because we you know, the invariant is that the depth is the number of items on the stack plus 1 or something, right? So yeah, so this is the length, right? Is the current depth minus the best depth, so that's just the number of nodes in between. And then this is the prefix sum version of, okay, well, this is the current rate. We want to, the small w is the current rate, and this is the prefix rate at that value. So then everything in between is just this thing. And keeping in mind that we add 1 because the cutoff, we don't want to count the cutoff. So this is the next depth after that, just to be clear, right? And this is just some comparison stuff. Hopefully you'll be able to get it. And then this is just resetting, right? So, okay. So now that we're done, we're resetting the current color, right? And that's pretty much it. Yeah, and then this is just recursion, right? So go to the next node, we add in the depth, we add the prefix rate, and then here we want to pop off this node, right? So here, so basically just reverse everything that we did. We pop things off the stack, we pop it off the number stack where we keep track of the numbers on this root path, and then we just update the segment tree to make sure that it is correct, right? And yeah, I think there's also one more thing that you could have done. But yeah, because basically I have a lot of if statements around here. You could also have maybe just on this list, we could have also like for C in set of nums or something, right? So for every color we can actually set this to -1, just to start it off. And I think that allows us to kind of get rid of all these if statements, because then they would all automatically be so then they should automatically exist. Let's double check. Let's give us double check submit. That'd be funny if it just times out because it's a little bit slower as a result. But yeah, as you can see, so we can have Sentinel so that it just sets up for the if statements a little bit easier. But yeah, and you can see that now we set the cutoff color, which is -2, which maybe is goes to -1, the second max. That's we move 1 cutoff point, so we choose it to be the 3rd max now, including these 2 colors, and then we just get the max, and that's it. What is the complexity here, right? Well, for each node, we visit each node once, right? And for each node, we do segment tree stuff. And so it is going to be n log n, right? Or n log m, where m is the number of distinct colors. There is an optimization that I can do here. So here I actually base it off m, which is m is the number of colors, which is actually the max of nums. One thing that we could have done actually is just remapping nums, renormalize it to 1 to n. So then if you do that, it's going to be n log n. And actually let us do that as a upsolve. If you don't want to see this upsolve, fast forward a little bit. I'm going to go with the cleaner solution next. As you can see, oh well, sending it to -1 is actually much slower than maybe it just creates a lot of colors though, I don't know. But yeah, but yeah, if you want to see the fastest solution, fast forward a little bit. I don't even know where I have it. Oh, one second. Fast forward or skip ahead. But yeah, but what I want to do is just renormalize this to m is equal to let's just say length of the set of nums, right? And then here maybe lookup color. I don't even know how to normalize things anymore. Lookup is equal to right? So for x in nums, if x is not in lookup, this right? Then lookup of x is equal to some current thing, right? Current is equal to 0, and then current increment by 1, right? And then now for I in range of length of nums, we can just remap the colors, right, to and in this case m is actually equal to current, and you can maybe even just use m actually. I'm going to change this real quick, right? And then now for each numbers, we can set num sub I is equal to lookup sub num sub I, right? So we do remapping all the colors, and here should make it a little bit faster, as long as it's correct, right? I mean, it'll be strictly faster. I don't know, it'll be fast enough. Yeah. Right. So it wasn't that bad actually to renormalize, but okay, actually doesn't change that much. So maybe the inputs just don't care about it that much. And also having Sentinel is actually a little bit awkward. Oh, this is definitely wrong now. Oh no, this is right now, but still a little bit awkward though. Actually wonder why that is. But I don't need this anymore. Maybe that's why. So I'm doing some really quick micro optimizations. I don't think that matters though. But I guess it's. I mean, it is faster than a default dig, but I don't know. Yeah. Okay. All right. Maybe I'm wrong on that. I mean, it is strictly faster, but maybe not by that much, right? It's okay. So so for the next part, I do want to point out again my video for the longest spectral path. It wasn't even that long ago, frankly. It was only like 2 months ago, and I was able to get that one pretty quickly. So today I just struggled, but the idea is the same, right? The idea behind that video, and you should watch it because I think I go over the prefix sum and stuff like that much more. And the code is very similar to what I wrote, but during the contest, I came up with most of the same ideas, but I just thought that the state matters more and not this idea of cutoffs, right? Meaning that all the colors in between your sliding window matters, and it does to a degree, but also not to a degree. Yeah, and what I mean by that is that, so here I don't like this window thing. That's how do I get this on the? It's so awkward to get it on the same window. Hang on. Sorry, technology. Because I want to focus on the code. That's why I'm. But that view is squished. Okay, so this is the code for not this problem, but for the part 1 of this problem, right? Which is that, okay, it's the same idea, pretty much. We can avert the adjacency list. We keep track of the best nodes and stuff. But the difference is that we have this idea of the last prefix, the last color that we care about. So basically, if you think about how we drew the tree and the cutoffs, right? Like we go back to the drawing board. If we go back to here, instead of doing all this stuff about getting max, all we have to do is just figuring out the cutoff, right? And if we're getting out the cutoff, that means that we can pass down the last cutoff, because that cutoff, keep in mind that this is for the distinct version, right? This is still for the distinct version, but yeah. So here, on every node, we're just getting the max cutoff and then removing it and then get the next max, right? Oh wait, no, sorry. For the distinct version, we're not removing it, but we're just getting this max. But keep in mind this max, well, as you go down the tree, it can only increase, it can only monotonically increase because you're only going to see more duplicate nodes and then cutting it off, right? So the cutoff only gets closer to you, which makes sense, right? There's no way for you to skip a cutoff. That cutoff is always absolute, right? And as a result, then you can just keep track of that cutoff. And then if the current node, so you only need to update the cutoff if the current node, the color of the current node that you're adding has a cutoff that's before that, right? So you only have to look at stuff before, and you can check that easily. And that's basically the idea behind this particular solution, which I had. This is the distinct version, by the way, the part 1 version. The part 1 version, yeah. So I have all this. Yeah, I mean, these parts are for the number of nodes. So it looks a little bit wonky because maybe I could put them in the same thing, but like a class or something. But basically, if you just ignore this part, because that's just the number of nodes, which is the tiebreaker. But the idea is the same with or without it. Is that you have scene, right? And scene will yeah, actually, I have the explanations here. Scene sub I is a stack where the colors I of is last seen, right? So that means that you can see that, yeah. So we coming into this node. What is the color? If the scene of this color, if we've seen this color before, then we update. We said. Well, if we've seen the color before, then we look at the last time we've seen this color on the depth, and then we just update last prefix. And last prefix is just the cutoff. I mean, the naming is a little bit awkward maybe, but I think of it as the last prefix that we have to care about and cut it off with, right? So we update the last cutoff with last prefix, right? We also update it for the number of nodes for the same reason. It's pretty straightforward, right? Yeah. And that's really it for this, right? And then now, after we update last prefix and last prefix node, we just do the math, right? So here, current minus last prefix. So this is again the prefix sum, but on the rate. And this is prefix sum, but on the node, right? And that's it. And then we just keep track of the state, right? We push this on the stack. So we do this a little bit differently. Because actually, now that I look at this is kind of weird. I don't know why I don't put, and this is for this one, right? So now that I look at it, actually, oh no, it's fine. I don't know. I think I'm off by 1 somewhere. That is a little bit awkward that we update the color of the current node with this. But anyway, as long as you're consistent, it doesn't matter. So I think it's fine. But yeah, we push them on the stack, and that's it. And again, this is actually much cleaner, right? Because this is linear time, linear space, because we don't have any log n segment tree type of thing. And yeah, and for more details, check out that video for sure. But now for part 2, how can we update it for part 2? Well, for part 2, it's actually very straightforward with the same kind of pigeonhole kind of thing that we talked about, which is that, okay, now, instead of keeping track of the last cutoff, we just have to keep track of the last 2 cutoffs, right? Because basically, you can think about this problem for having one color with 2 distinct things one color with 2 items is that we can just skip 1 cutoff. That's the only case, is that we have 1 cutoff, we remove it. That means that now 1 color, that color that we just removed from the cutoff, that color appears twice, and then but you're still blocked by the second cutoff on the tree. And that's really the idea here, is that, and it took me 5 minutes to write, maybe even less. I don't know. You could watch the video. It's just that I converted. So the reason why we have to copy over is because I actually converted from, before it was 1 element, so you're pushing on a stack, but now I just converted to 2 elements, which is the best and the second best, right? 2 best, and that's it. And I had to make a copy because when you pop off a reference, it doesn't actually change the values, stuff like that, where before it would have stacked automatically. Hopefully that part makes sense, but yeah, we just make a copy of the input so that when we manipulate it, we get to pass it to the lower better, right? So yeah, so here we have the last prefix and last prefix node, and everything is exactly the same. If you look at the part 1 or the first version of the code, or yeah, the part one, the special path part one of the code with this or this thing, and here all I change is that these if statements, so that now it takes care of the top two, and this is also takes care of top two. We do the math based on the second best, because we could skip the first one, and this was strictly better than skipping none, right? So that's why we always skip it. And again, this looks exactly the same as this, right? Except for that I looked at the first element, and that's it. Everything else is the same, honestly. I mostly copy and paste. The only thing that I changed was these if statements so that it handles two best, and I make a copy here, and here we just take the second best instead. So yeah, I'll make this slightly smaller so you can see it all. But yeah, this is just, again, same thing, setting up the tree, setting up the graph rather. This is the recursion with the kicker, and yeah, and scene is a stack, scene nodes is a stack, last previous, this is the last previous two, and yeah, if you don't want to do this copy, you could add more variables into the caller function, but I don't know, whichever way you prefer, and that's it. This is also linear time, linear space, because we just do a few more extra if statements and assignment statements, but everything else is exactly the same, right? And yeah, yeah. That's it. That's all I have with this one. Let me know what you think. Thanks for watching. And it took me a while, right? So I didn't get this one during the contest. But if I had remember how I did the first one, maybe I could have. But it is what it is. I thought I could do it with the sliding window, but and I think the idea is right, but not the time is like it's correct, but it's too slow. And I couldn't figure out the idea behind the cutoffs for this problem. I thought that because when I was thinking about sliding window, you need to know all the intermediate stuff in between, but it turns out you don't. At least not in the same way. You just have to keep track of the last 2 or 3 times you. Well, I mean, you have to pop them, so it's more than that, but just the depth of the colors, and you kind of get that. Yeah, it's very frustrating just because I feel like I should have been able to get this, but sometimes it is what it is. And yeah, that's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you could watch me solve it live, especially the upsolve during the contest next. I rushed it too much, and in rushing it I took too long, but oh well, it is what it is. All right, let's go Q4. Only 87 people got it, which is a little bit of a cheating thing. I mean, at 30 minutes, actually, no, if I had opened this contest, maybe like 2 people would have gotten it so far, but oh well. So I would have maybe taken my time a little bit. 87 is still not that many though. How much time do I have left? I have an hour, literally an hour left, so okay, let's go. Give it a tree. You have a length. Okay, that's fine. Tree with lengths. Downward path from an ancestor road. One value may appear twice. What does that mean? Length of the long. Okay, so special path from an ancestor road. Do we get to choose which one? Of the length of the longest special path. We saw once the minimum number of paths in all possible longest special. Okay. And that's fine. But we have to figure out which ancestor road node. Is that it? I'm still not quite understanding. Okay. Oh, no, it's directed at 0. Okay. Rooted at 0, sorry. Okay. Downward path from... Okay, so now that we have... Okay, so there is a direction. So what is it asking? I mean, just DFS kind of thing, right? Or am I misunderstanding this? I mean, I think there's some sliding window type thing, but maybe it's a little bit tricky. I don't know. Nums is what? The number of of the value. That's the value that we're trying to dedupe except for one value, right? So it's like a sliding window, right? I mean, it's just sliding window except for we are from a tree, right? How do I do a sliding window recursively? Or maybe more importantly, how do I make sure that no, okay, no, don't wait a minute. I just want to make sure that it doesn't time out, I suppose. Okay, I need to go to nums, I suppose. Okay. We want so basically the environment is that if we have two values that appear twice, that's no bueno, right? So okay, so how do I write this? Well, first let's construct a thing, right? Okay, and we want to root at 0. So okay. Sliding windows. Right, so then basically, yeah, maybe if you want to think about it, sliding windows, then here you might have the current node, the top of the node. But the thing is that you have to keep track of what that branch is, right? So you have to be a little bit careful. So you have to keep track of the stack almost, right? But okay, fine. It's just implementation. It's just sliding windows, but not a easy sliding window, of course. So you have goes 0. Maybe we want to say the window is because the thing is, if you reconstruct a thing every time and at every node, this will be n squared if you're not careful. Right? Because you have to undo the slide is the issue. No, you don't. You just keep track of the entire path and then the left and the right. Okay, fine. That makes sense actually. Okay, so then now maybe we have a core stack thing. Okay, right. And we want the left side of the window and the current node is the right side of the window. That's fine, right? So then left, yeah, and then maybe we push this thing first, right? Then here the left and the right window. No. We could do it here, right? And then maybe the something like that for the distance. And then what? And then now for UV L in what am I doing? For VL in E of node. Also I guess we have to have parent just so that we don't go back. Though I guess it's on it's the thing on top of the stack, but it's just easier. Well, I'm just too used to it maybe. Okay, then we want to go, right? So we want to go, we node left we don't change for now, right? Okay, but here we append this to the thing, and then now the 0 is wrong, but that's fine. Okay, so this is going to be prefix sum e stuff, right? So that's also fine, right? So then here we have total weight, and then this is weight plus L, so here prefix sum. Okay, so that's the structure. And then now the sliding part of the sliding window is that we have, okay, so that means that we have we have to keep track of stuff. Numbers can be pretty big, so we have to keep track of. How do I do that? Okay, we can keep track of the path and then recurse, but then now we have to keep track of what's dupe, except for one number. I'm trying to think whether it's easier to do backwards also from the leaves up. Can you? No, it's still state dependent in a way. So we have to make a set of the set. How do I keep track of that in a fast way? Because you have to unwind it, right? That's the hard part. I guess we just have to kind of unwind it manually. Previous left as you go to left. Right, so this is the, and then maybe we have an F for okay, then now we want to say F of num sub node increment by 1, right? It's just an implementation problem. Do we want that, or do we want to set? It's just so many if statements. It's so annoying. Okay, so we have scene, and then the dupe, right? So here dupe is, let's just say none actually, right? Okay, so then now if num sub node is in scene, and if dupe is this is so annoying. The dupe, I mean, it's just a lot of annoying code and state and unwinding, right? So with none, then dupe is equal to num sub node, otherwise we have to get rid of it, right? So, and this is the window part of it, right? And you have to write it this way a little bit, because we have to maintain scene and dupe state. Okay, fine. All right. It's just such an annoying thing to write. While num sub stack of left of 0 is not equal to dupe that's weird, but okay. Well, this is not equal to dupe, then left increment by 1, and also scene dot remove this thing, and then we remove it by remove it. And then now we dupe, then dupe, and you go to num sub node. Right, okay. So this by itself should be good. But then now we have to add it back in, right? So now we have to add it from P left to left. Right. So here we pop from the stack, but also for I in range from left, or from P left to left. Is that a left or left plus 1? That's what I'm hesitating on. I think it's left plus 1. We have to add the numbers back in. To unwind. Okay. Okay, so then now we have what do we longest and min nodes longest, right? And then well, maybe just and maybe this is infinity, doesn't really matter. There should be at least one node. That should be fine. And then here, oh, this should be after this, which is that if, so okay, so length here is going to be equal to length of stack minus left, maybe it's off by 1, should be approximately right. No, but that's not the, I mean that's the number of nodes, but the rate is going to be equal to the top of the stack minus, yeah, okay. So then if W is longest, then longest is equal to W, min longest is equal to length, right? Else if they're the same, then if length is smaller than min longest, then min longest is equal to length. I have to make them non-local. Something like that. I don't know if this is right. I mean, this is probably not right, but or not. I mean, the idea is right. I don't know if this is precisely right. Like in Q3 where I just struggled a lot. Right. Did I miss a method? 1, 2, 3, 4, 5. Parent left. Oh. Parent left. Wait. Prefix wait. Oh, did I change? I don't think my. Oh. 12, 5, 5, 5, 2 is right. So we have something. Not everything though. Okay. Why do I even get 12? Right? We could print it here, right? So print node stack left, say, so every time it's longest. Maybe I also print out W and L actually. W is 12, so okay, so this is the thing it took, right? Actually, it should also print out scene and dupe. And technically speaking, I guess this could be a lookup table, but I'm still thinking of it from sliding window, that's why. Yeah, I guess so, but set is not correct because we don't add anything to set. So this is right. This is probably right if I didn't have dupes or anything. Okay, fine, right? So here, how do I write the thing? I didn't even do it. Oh, there should be else. I think that's it. I meant to write it that way, but then I just forgot because I was trying to get the other part. Okay, still 12 to 5. Okay, so here values. This is not right. 0, 1. Oh, they have the same color. Okay. Oh no, it's right because the dupe value. Okay, fine. How do you get 12, 5 though? We go down to 2 and 4. Okay, so at the 4 you have to pop the 0. Oh, that's the. I didn't handle that case at all. Basically, yeah. This is so annoying. Too right. Maybe it shouldn't have been seen, but yeah, maybe it should be just a collection that counter. Or maybe just a. Okay, let me write a helper object actually. Whatever, I'm too lazy to name things. I couldn't figure it out. Counter, right? And then here we want to add a value. And if this is equal to if we go from 1 to 2, then sub.dupes. If it goes from 2 to 1, then Okay, right? So then now, let's just do that, right? I don't know, naming things is hard. F maybe, right? So then now we go f dot add num sub node, while f of dupes is equal to we have more than one dupe, then we have to move left, and we move left by f dot remove num sub stack of left of 0 for the node. Okay, right, something like that. Okay, scene is not defined. That's fair. Where did I add? Oh, I forgot to change everything. Scene not found still. Where do I have scene? Oh, we have to add it back in. Right, yeah, so add f this thing. Alright, just do this. I guess maybe it's off by 1, but hopefully this is right. This index our range. Num sub, this is the index. It goes out of range when this is, but this should not, because of the invariant. Something like that, maybe. Just want to print things out. Right, fine. Yeah. Okay, I mean, this is what we thought would happen, but even here, oh, it's not just dupes, that's why. But this should not have, I don't know. This is weird though. Oh, no, this only goes from 1 to 2. Why would it go out of bounds then? What left? Oh, maybe it's part of the other things. I don't know. Alright, let's print a thing here. Okay, yeah, so this is not on this branch. Is that the second input? Or I don't think so though. No, it's still the first one, I think, yeah. And this is on node 8. So it's here on the right side. I don't know. But we still gotta fix this part where it has 4 of one number, right? So, okay, so maybe I need a good function. I'll keep track of this. I mean, there should only be one thing, right? So, and this should only be whatever, right? So, because this can only be true once, because we are always removing it. So, okay. Okay, so then it's gonna be this. Or self f dot good is not true. Okay, so something like that. Okay, this fixed this part. This part may be a little bit wrong, but is that for part 1 or part 2? Okay, still part 1. But yeah, but we go. So node 4, node 7. Yeah, no, I mean this is right. So I'm happy. It may be that this maybe we don't add stuff back in correctly or something, but because we do the recursion states not so well, maybe. Okay, let's look at the stack. Actually, let's. Okay, so this is the stack 0, 1, right? Also, this is just wrong. There's 6 ones. Oh, this should be a remove. Oh, no, this is add. We add back the stuff that we remove. Right? But why is this 6, 1? So something is really wrong. And that's why it is out of bounds. Okay, well, I think we have to make sure that our cleanup is good. So that means printing the innies and the outs, and they should match. And I thought they would be, but I think we're mostly done conceptually. How much time do we have left? Half an hour, so it took a while. It wasn't that fast. But okay, so in, out, something changed. Oh, left changed, but that's fine because that gets popped up the stack. So we don't fix the counter. Huh, why is that? So that's probably what's up. Okay, so right? In fact, we have to remove this node as well. We have to pop off this node, that's why. Okay, fine. So F remove num sub node. Yeah, at the very least. I don't know if that's the only thing. Okay. Still a 0. So that's no good. And 7 has no children, so it really should not be doing anything else. Right? Do I add this back in? Maybe this is wrong. That's why I wasn't sure about if I was off by 1 there. Okay. I mean, it gets the right answer. Is it right? Unclear. Get rid of print statements. Where are my other print statements? There's one more print statement. Okay. Let's give it a YOLO submit. Am I confident? I don't know. If it times out, this is probably my sketchiest thing for n square. But honestly, I'm not sure. Like that should only happen for one. Every time you pop, but I can see how that is the case, but it's still anytime you pop. So maybe it is just a pop thing. I'm gonna use the bathroom real quick, but I have to think about this. I think that's the only sketch part. Yeah, in terms of running time, I think that's the only risk. I mean, this is the only part that is sketchy, and possibly because as a result, this one as well. And this is if every node is the same. It looks like, right? Every node has the same value or something. Oh no, this is just like a tree graph. But I don't think the tree does anything for me. Maybe it does. I don't know. Yeah, and they have the same node value. Oh, I mean, I don't know. I don't know if it's a tree or not, but it just all has, or a lot of them has the same node value, which I don't know. That shouldn't do anything. I mean, we only remove this once per node, so it just depends on how many times we do this, right? And how can you? And on each node we should amortize, right? No, I see. So you could have a node that goes. I thought I took care of this. Maybe not. So this. So you have a long linked list that goes in the star graph. It slides all the way down. No, because that only does it once, right? Oh no, but if you do it in the children, in which it has to slide from the children, right? Okay, so I have to do some prefix. I don't know how to do it then. So the sliding window idea is not quite correct. I have about 26 minutes left. I see, because it slides out. But then how do you do it? The peer twice thing is weird. At most, right? Is it just sliding? You know, it doesn't have to be sliding window. It's just the last. So basically, it's the last time you've seen this node, but limited by another node, right? So it's almost like the max of. Is it a sig tree? Do I have to do a sig tree to kind of keep asking that question and then keep altering it? So that would be annoying. Is it always? Is every problem a sig tree problem? I thought I could do a sliding window, but maybe not. Maybe that's fine. But okay, maybe it is. Let me find my template. Yeah, okay, fine. Wait, is that right? No, that's not quite right, right? Because it can have. That's okay. Because it can leave out. So how do you do it? So basically, this one value appear twice thing is a little awkward. This thing would have been much easier. Okay, so they're given the current node. This is a bad edge case actually. Definitely should have timed out because I'm doing loops every time, but can I try anything else? With 22 minutes left. Binary search up to tree. For each, no, I don't know that you could do that easily. Huh. I thought sliding window would be fast enough, but because I thought the cost got amortized, but I was wrong there. Yeah, that makes sense, but That one value appearing twice thing is the hardest part. Can I still use set tree in that way? You have set tree, then you repeat. Now this star graph thing, I don't know that sliding window because that means that you cannot afford to slide. No, because then you have to have a prefix on those. Okay. Does it make sense to go back upwards? Is that the path that I'm struggling with? If I'm going upwards from the leaves, then is there a greedy? Because that depends on the nodes, right? Because we're going from go up, then you merge. You have some states, right? But then it depends on the nodes, right? It's not just the best value at this node. It depends on the states, doesn't it? Spent 10 minutes not doing anything, so I don't know. Am I getting this? Maybe not. I was wrong on my assumption. Can colors mean anything? It's not just the closest, right? Because here 6 and 1 are closest, but then 8 also attaches, right? So then how do you factor all that in? One value that may appear twice. The thing is that outside of those you can still have values. Okay. How do I do it backwards? How do I merge two things? So okay, so let's say we do a recursion, right? So we want to get two things. One is the longest. I guess that maybe is the way to do it. It's just that I did it the other way with the sliding window. It's just recursion where you return two things. One is the best inside, and then one is the longest that continues, and as a result and then merge it that way. Does that make sense? But how do you compare two results when they don't overlap on the same thing? I mean, the subtree thing is easy, but what about the continuing one? Because the state I mean, okay, let's see. Okay, what if there's no dupes? If there's no dupes, that means that the dupe is just one node away from the no dupes. No, that's not true, because you could keep extending. That's the problem, right? How do you combine them? So okay, so let's say you have no dupes. That one's easy, kind of. I mean, I don't know if it's easy, it's easier. That means that the next node that you add is going to be a dupe in either direction. Huh. Maybe I don't know this one. Give it and just like that. Man, these minutes are going by fast. Okay. Okay, well, let's say this is 2, right? Then what? Then... So it's just an extra query? Is that it? Maybe that's why. Okay, well, let's see if that works. I don't know anymore. Also, we don't have that much time, but... yeah, let's see. Where's my pipe? Maybe that makes sense. Actually, I forget that I mean, I didn't forget. I just didn't think about doing it again. Okay. I have something like this, right? I don't know if this is right, but and this is fine from 0. Okay, fine, right? So then now, okay, so with edges, with all these things, we want to say, I don't know if I'm gonna get in 10 minutes, but all right, let's try to solve the one without dupes first. And then what does that mean, right? So we want to get the last node of all these things. So it's going to be on the max depth, right? So we have stack, say, we have nope. No, it's fine. It's fine. Whatever, let's just set. Right. We put a stack. We put. We want to set the node. To. Why is n none? Anyway, we want to set the node to the depth, right? So here, okay, so depth is going to be whatever. Actually, maybe it should be -1. So 0 means something, but it doesn't matter, right? So set depth, right? Okay. Okay, right. I don't. Okay. Let's try the undo version, right? So okay, so we import this. We have to get the max. Whatever. Actually, of the entire tree, right? Is that what I'm doing? What am I doing with sig tree? I forgot. Okay, so we want to see what the value is. Do I keep track of the value? I don't keep track of the value in this one. We want to get the maximum depth of everything in the... No, because there's no dupe yet, Larry. What are you doing? You know what that depth is? Okay, that's fine. Why do I need a segment? Oh man, I had the idea of a segment tree, but now I've forgotten it. How do I do with a segment tree? Okay, well I'm not gonna solve this in 7 minutes, I suppose. Okay, we want to keep track of the depth, right? We go n minus 4. I don't know anymore. Why am I using a segment tree? I forget. I can't figure it out. I thought I wanted to do it on the depth thing, but what am I doing? Get the max depth. I had some. Everything is segment tree. It's good practice though. I'm not going to solve it during the contest. Oh, let me take a screenshot of the other stuff before lose it. But okay. You have the colors. Why do I need a segment tree? What am I doing? I want to be able to go. Okay, we want. So these are all the things in there. Okay. We add this node. Okay. I see. I want to set the depth of things, right? So then you have the max of all the nodes that are duplicates. And then just, I think I get it. I'm going to use the bathroom again. Okay. I think I have the idea, but again, I don't know. I definitely not getting in however long minutes, 3 minutes. But okay, so keep track of where everything's been, right? Maybe. So okay, so stack is equal to we have a different stack, right? So maybe stack. I don't know. Right. and the depth matches the stack. Okay, so then here you want to say, okay, we append this, but we also want num stack of num sub node dot append node, right? And we have to get rid of it at the end, I suppose. So stack dot pop, and also num stack. Okay, and then now that means is that if nums stack nums node, if there are two numbers, then we want to set num sub node. Oh, then this is not n then, right? This is actually, what's it called, 5 times 10 to the 4th. Maybe we can re-index, but I'm not gonna. That's actually annoying. I mean, you should be able to re-index, but it's just I don't know. We'll do this for now. I don't know how we should be able to re-index to squeeze this to a tighter bound, to bound it by n, but we will see. I mean, we run out of time anyway, so we'll see if this works first. The idea, we set the node. So this will give you all the places in which, given the current node, that's the last node in which it would give you the thing about, right? Right, let's get rid of these things for now. I don't know what they do anymore, but right. But we also have to clear this, right? Because after this, if after we pop, this goes back to 1, then we can set, oh, we didn't set this. We set the node, is that, yeah. We set the node to the second depth, right? So num stack nums node of not -1 but -2, because that's the limiting factor, right? Here we set it back to -1. We need to set this anyway, right? So we need to reset this to the previous one. So yeah, okay, fine. Yeah, it's very awkward, but it's fine. So we reset this, right? And then now this gives us this number. So this number would give us the depth in which we care about, where we have no dupe. So how do we get rid of one dupe, right? Well, we get rid of one dupe by this gives us the depth, and the depth gives us the node. So we just have to, right, previous depth is equal to this, right? And the depth is corresponded to stack. So stack of previous depth, we have previous node and previous weight is equal to this. And then we do it one more time, maybe, in terms of okay, so this is the last stack. So then if length of nums of stack of p node nums of P node. So we want to remove it temporarily. P node Larry. We want to make it okay, wait. Okay, so that if there are two nodes, then for that node, we want to remove it to the third node, right? So okay, so yeah, by definition, everything here should have two nodes, but if it has three nodes, then we convert it to here. Else, we set it to -1, and then now best step from here. Again, get max. Do we care about the node? Maybe not. I don't know. But we know what the depth is. So then now best node, best weight. That's the previous weight is equal to stack of best depth. This will always be at least 0, so that's fine. And then, oh, I guess I deleted the weight thing. Maybe I could have. Okay, fine. Leetcode, silly Leetcode. I know it's because I'm out of time, so that's why it doesn't show up. But I just want to copy off this code since I already wrote it, and don't have the brain juice to think about it. Well, maybe I do, but I don't want to. I'm lazy. Alright, so it's not left. It's going to be best step, and that's it, really. So I did. Oh, actually, I just commented out. Maybe. Oh, I have to reset this. So then, after we set this stuff, we want to convert this back, right? I think technically this is. I don't know. There's a lot of like. I don't know if I did everything I need to do. I mean, the idea is not that bad, but yeah. Okay, so the weight times L. Oh, I guess I removed W on the way, somewhere along the way. And it's not left anymore, it's depth, so this is depth plus 1. Okay, I mean, this is some answer, and it's fast enough. It's the wrong answer, but it's fast, right? Which, well, I don't know if it's fast, but it's fast enough for at least these inputs. So we can kind of look about it. The 0 is a little bit awkward, but I think the idea is right, actually. It's just taking a long time to get through to this. It is a little bit awkward for sure, though. Okay, so we can kind of just go, okay. So we have the node, let's say for a given node, we have L and W. Right, so we can kind of just take a look real quick. Oh no, it's going to give me a huge list for the other one. Okay, fine. Let's get rid of this case. I mean, I think now it's fast enough. Is it right enough? I don't know, but it's fast enough. So let's just debug the other things. Okay. So 11.4. Actually, the 0.2 may be more interesting. L is L is weird, but W is also weird. this should be W, because W is the top of the stack anyway. But best step for each step of the way. 0, the best step is -1 is awkward. Best step should not be -1, right? Because we always set. Oh wait, we don't, because we always check it as the thing. Okay, so the best step being -1 would mess that up. Okay, that's fair. I think maybe -1 is silly. Maybe it should be all zeros actually. Okay, so this gives me the right answer for here, which is fine. This is a strictly better answer, which means that we did something wrong, which is probably fine. Best step is 0 in the entire way, so that's kind of wrong. On note 4, I think we want best step to be... Actually, I guess it is 0. So maybe I did mess up on the Z. Okay, so I think what I need is actually, we do need 0, but we actually want to start the depth off at 1, and we actually want to start the stack off at -1, 0. Maybe? Now there's more nodes. So my base case is a little bit off, that's why. I think this should be -1. Or maybe this is 0, because I don't think because the W should be a prefix sum, and I think I'm not. No, that's okay. If this is the case, then the prefix sum, the W part is right for the prefix sum, I think. But then the node matching is wrong. Because by default it goes to 0. This should 4 should return 1. Why is it not? 4 should return 1. Because okay, so here we say then we removed it. Okay, so that's why it returns 0. Because we're saying oh, okay, so it's not this node, it's the node afterwards. So this is the node in which the issue happened, so it's the node after this. That's why. Okay, so I mean this part is fine because that's the node we want to remove, but best step should be this +1. And this should be -1, I think, maybe. Okay, let's give it a quick submit. Okay, well actually let's put this real quick, because why not? Should be fast, right? And it's right. Oof, wrong answer. That's tough, that's tough. Getting for a huge case, but not this one, is a little tough. But it seems like maybe it's an off by 1, right? I only have 3 nodes, 4 nodes. Let's draw it out. 0 to 2, 2 to 1, 3 to 1. So this is a what 4, 5, 4, 5. So for me, we want to remove the 5. So the next one is 4, so it should be 1, right? So okay, I know what it should be, but what was it actually doing? On node 3, the best node is 0, which is not true. Do I reset something incorrectly? We reset this. Rest 1 node is -1. Yep, that's fine. I mean, I don't know that we are resetting it, but so this should end at 1 because this is this +1. best step. Yeah, that doesn't make sense here. Right? So the previous node. Previous node is 3. So that's wrong. Does negative 3 go over? No, no, it's here, right? Previous node being 3 is weird. Oh, wait, this is also weird. Oh, no, this is right. Probably could have been this is why I was a little confused, but So previous step is -1. That's wrong, right? Because on 3 you have a 5, so you do have a 5. Right, so we're so close. Yeah, so on 5 of 1 and 3, so then the max should have been 1, right? Is my search tree incorrect? Does this have to be N? Am I just like... Oh, it's not N, it's M. I am dumb. Okay, I see. With I have another place, right? Okay, I see. Okay, still wrong, but do I have it somewhere else? And is it M or M plus 1 or M minus 1? This is wrong anyway because M should be M. I don't know that I always forget whether it is off by 1 or not, but in any case, or like, okay, so I mean this is I don't know if this is a better answer, but it's not wrong for the reasons I read before. Obviously this is a little bit worse, but okay, so the node on 3, I didn't draw the edges, so okay, so 1 2 is 10. Okay, so we definitely want that, and we want the 4 5 4 instead. So what is it here? We have 14. Why is it 14? We have 10. 0 to 1 is oh no, it wants to 5 1. Okay, so this should be 15. This should not be 5, so I was wrong. 14 is the wrong one. So this one, of all this stuff, right? We get the previous node, which is at 2 0 1 2. That's not right, right? Previous step is 1, which is here. Previous step. So then the previous node is 2. Oh no, 2 is right. But maybe my no best step plus 1 is fine. Okay. So we have 2. Right. 2 is the right node. Okay, fine. So then now we want to remove it, and we do. Then the best node, or best, where is that? Best step is so 3 best step is 2, which is way not right. 0, 1, 2. Oh, because we no. Huh? So the tree should be 0 and 1, which is how we return. Yeah, how we return the 1. We remove the 1, it should be whatever, right? Is this wrong? Previous node. It has 3 things. Nums of pre-sub node. Nope. And then the last 3 things on the stack, right? Yep. It should be set to -1, so that we should see a set to -1. Okay. So then why is the get max not right? Why does best step? Is my max wrong? No, it should be pretty straightforward, honestly. Set left, set right, set max, right? So yeah. Okay. Yeah. Okay. Well. Before is 1, after it is 1 is way not right. So that's why it's wrong, but and it should be on node 5. Do I not set it correctly? We set num sub pre node. I mean, the P node shouldn't have changed a bit, or the previous. Okay, so it changes 4. 4 is not the 1, that's why. What? And 5 is the one having the issue. So this is the previous step. Is it because I'm, I think maybe it's because I'm doing this. Nope. Why is P node 4? Or nums of P node is 4. I'm so confused. Okay, what's the previous step? What do you think it is? It is 1, right? Which is true. Oh no, 1 is the maximum depth, yep. But stack is not right. I guess that's why. So 1, what is the element at 1, right? Element at 1 is here. Why is that not mapping correctly? It should be this one, that's why. Am I messing this up? A stack? Oh, I am dumb. Okay. Yeah. Wait. Yeah. Okay. I'm dumb. I'm dumb. That's just a silly mistake, but and where's my long one? Okay, well, I don't have the long code anymore, it's fine. If it still times out, I'll be a little bit sad. But I think this is okay. Oh, I have a print statement still in there, so maybe that's why. Let's give it a submit again. I mean, this should be analog in, but I don't know. I mean, yeah, that should be on. Yeah. Should I have gotten it? I don't know. How long was I off time? Let's see. By 25 minutes. So it took me an hour. I have to do this one. Yeah, I mean, it's a hard one. I honestly thought I could do it with sliding windows, but I was wrong about this. I want to. It's kind of tough because every problem that you can solve, it feels easy, and after you solve it, it feels like, oh, it's not so bad. But no, this one was a struggle. But I'm trying to figure out, like, my first thing I want to think about is just how to get better about this in the future. I don't quite know yet. Let's see if my Discord say anything useful. Is there longest special path 1? Is that that's what someone on my Discord is saying? Maybe it's easier that way if you did know it or something. Let's see. I did do this one. So what did I do that time? Maybe I should have looked up what I did do that time anyway. Seeing the color before. I mean, I did do this with recursion. I mean, the scene no. Oh, this is for the dev. Yeah, this is to push stuff on the stack, and then keep track. Yeah, I mean, I think one thing that I could have done better is definitely seeing what I think I was stuck a little bit on sliding window because maybe recently we've been doing sliding windows problems. I mean, I had these ideas pretty quickly. I mean, I put them in one stack instead of 2 stacks, but I did do the same thing. So I don't know that how much I could have done better on. I think segment tree is an interesting idea. I don't know if people did it with segment tree on this contest. Could I still? I mean, I was trying to get this to work basically, right? And was to cut off. I mean, this is basically what I was trying to do, except I was doing it with sliding window. I guess I could have done a lookup. But the thing with the lookup is that by the time I knew that I need to do it, I wasn't sure that I could do it with the exception. I think that's the tricky part. So it wasn't like so what I'm trying to do now is just try to figure out if I could have like took this solution and then like just made some modifications. And I don't know that it's not clear to me that I can. Maybe I could have. Because then now it is just about maybe I could have. Maybe I let me see if I can upsolve this actually. Because then now it's just keeping track of the 2 max elements, right? Maybe. Yeah, right. So maybe I should have been able to do it. I wasn't thinking. So okay, so this. Yeah, this is where we're at to. I don't know that I need segment tree. So okay, so this is what I had, edges and colors, which is actually honestly the same thing, really. So maybe this is actually the same thing. So let's say we have this then, right? Like the signature is the same thing except for its colors instead. Okay, so let's say I have this, right? Then now last prefix node, right? So we just have to keep track of two things, right? So that maybe is why we're able, maybe I should, everything else would be right, pretty much. Let's upsolve this way. I mean, oh yeah. I mean, these answers should be strictly lower just because just because there's no exception for two nodes with this one color, right? So then here we want to, so this is the last cutoff of the, okay, so update cutoff, last prefix, and there's so many things. This is scene, this is last prefix. Okay, so maybe last prefix. It's a little bit annoying, but it's just converting it to using two numbers, right? I think that's the thing. Something like this. I'm honestly not quite sure what I'm doing here. That's why I'm like a little bit sketch. Do I return the same thing? Actually, I need to see what this is return. All possible. Okay, yeah, so it's the same idea. Just want to make sure that they didn't change anything else, at least with respect to this. Okay, so the previous time we've seen this node, so that's what this is saying. The previous time we've seen this node. And then the previous edge that we've seen this node, so update cutoff. And then now, can I do it without segment tree? Because the thing is that, okay, so you have, I mean, it should be, right? Like, I don't see how that could not be the case. But that's why people got it really quickly. But update cutoff. Man, I even had comments last time, I don't remember. But okay, so last prefix, we have two variables, right? So yeah, okay, fine, right? So so we update previous, right? So how do we want to store last prefix? Last prefix is, so we want two cutoffs, right? I think that's the thing. Yeah, right? So yeah, I think that's fine. So then now if previous is greater than last prefix of 0, then last prefix of 0 is equal to previous. Okay, I mean, this is, come on, Larry, well, I was gonna say that you've done this a million times, but apparently I got it wrong on Q2, so, or Q3, so it's pretty bad. Okay. Okay. I don't know why that I don't have to do anything special for it, but okay, fine. I've done it a billion times and I still can mess this up. Okay, so then now we update that part, and then now if previous node, last prefix node. Yeah, prereqs. I was like, this looks weird, but sometimes when you type a word enough times, it looks weird. But I was like, that looks even more weird than that, though. So, well. Copy and paste where things go wrong. Okay, so then now, this should be just, yeah, the smaller version, and then that's it. Actually, if I had done it this way, then maybe this would have been really, okay. I can see how people got it in like, ooh, wrong answer. Huh. Did I mess something up? I double checked to make sure that I didn't mess something up real quick. Oh, here. Does this make sense? I don't know if I get the node part right. Well, I mean, this is wrong for both cases anyway. But 0, so this is like similar to the other one, but let me draw it out real quick. With 0 to 2, they're both 4s, so they're both the same color. And then 0 and 1, and 1 and 3, right? So the answer should be, yeah, 0, 1, 3. So why am I not getting that? Dun, dun, dun. Why am I only getting 6? Oh, the reason is because I assume yeah, okay, that's fine. Yeah, okay, fine. It's because I'm modifying these things, that's why I'm being a little bit careless here. We can actually copy over. This one is easier to copy over because it's only 2 numbers versus the way that I was doing it before. Yeah, oops. Yeah, okay, that's not so bad. I guess I just didn't have it today. I think I was trying to do too much. I think I'm missing, the key concept I'm missing was that I can just treat the extra 1 as skipping 1. And then doing it, it's almost the same as Q3, but yeah, I don't know. Yeah, and this would have gotten like maybe even with a wrong answer because I'm dumb, but this would have been like 5-10 minutes if I had just looked up my old one, but that's fine. I mean, I did learn something with segment tree, so that's not like the worst thing in the world, so I'm not too sad about it. But given that this is a thing that I've done before, I should have gotten it. Yeah. Oh well. This is, when people say that, like, oh, you've seen it before, you would be like, no, I don't remember anything, because some days I'm just really bad. But I had most of the idea. I think what went wrong was that I was not able to reduce what I meant to have one value appearing twice. I think I was trying to do too much. If I was, and I missed a critical observation about what it means as a variation of the first version. If I had the first version, because I had most of this code, but I didn't understand the idea of cutoff, and instead I was thinking more about sliding windows, and that kind of took me on the wrong path. Oh well, it's gonna happen, and maybe I need to practice more, but yeah, that is all. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this contest, and yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.